Jasper's session. Give me 2 seconds while I set this up. Okay, there we go. So, and I realized, I like the way he approached it because we come here, you guys come here, and then all of a sudden, we just magically show you the trace file. And that's good because you're all here to learn. Everybody's here to learn. We all learn from one another's session. I was at Warner's layer 2, where you learn about things like flow control, the LACP, the lags, etc. So it's all a learning experience for us. But I think it's also important to give you the school of hard knocks, right? So in the U.S. there's this concept of school of hard knocks, meaning, you know, it's what Saki's, I think it was Jesper that said it too. The experience that you get is right after you needed it the most.
Yeah, after you needed it most.
After you needed it the most, right? So the only defense against that is gather as much experience as you can. So I switched up the trace files a little bit today, and I want to give you some, don't do this moments. And I'll give you an example. So many years ago, not that many, this branch was having an issue. And it was actually on my way home. So I got sick of hearing the complaints, and I said, you know what, I'll tell you, I'll stop by the damn branch and see for myself. So I called operations, and I said, look, I'm going to have to create a span port because I knew I was going to have to capture packets eventually. So I show up on site, and the office manager says, okay, we got about 150 traders and consultants here. You're not going to do anything dangerous, right? And I said, no. And I jinxed myself right then and there. And I jumped on the switch and the router, and I checked it out. And I made a rookie mistake. I checked the MAC address. And I said, yep, this is good. Go ahead, span this port to over here, where my sniffer, my Wireshark was going to run. What I didn't check, what I should have checked, was the truncate, right? So when I thought I saw the MAC address of the port that I wanted, it wasn't. It was just coming across the trunk. So what did I do? I created a layer 2 loop. And it sucks for me because someone had turned off span tree. Okay? To save 2 packets a packet every 2 seconds on a 50, 60, 70,000 packets per second network, someone turned off the insurance. And yeah, I can fall back to, well, someone turned off span tree, but ultimately I brought the entire branch down. And it gets worse because when I saw my utilization of my Wireshark go to line rate, I said, aha, I found your problem. Somebody's using wire rate. And then all of a sudden I realized everybody's like, what happened, right? So to Jasper's point, I got it. I found the root cause. Oh no, I caused that root cause. And the whole branch is down. And what happens when you create a layer 2 loop? The only way to recover, turn it off. So question for you guys. Why is there a loop in Ethernet? No TTL. Ethernet has no concept of TTL, unlike IP. Because at least in IP, you can wait it out, right? Whether the TTL is 64.128, after it loops that many times, it stops. It's loop prevention. Ethernet has no concept of anything. In fact, how does Ethernet chipset know that the signal coming into your Ethernet network card has finished? How does it know that the frame is finished? Anybody know? Because I asked this question to Rich Seifert, who was a keynote speaker a couple years back and also the author of Dick's Ethernet standard. There isn't. When it stops transmitting, it stops transmitting. When it stops receiving, it stops receiving. Okay? Which is also the reason why there's an interframe gap, so you can do house cleaning, which is also the same gap time that if you saw Warner's session on why that 5.12 micro, second comes from. Okay? Long-winded way of saying, a lot of us say we know TCP, but we really don't know TCP because it's always changing and different vendors implement different stacks. So your job is to know it inside and out by reading RFCs and books, doing packet captures, learning the normal and the abnormal behavior, and learning how to distinguish it, and get so good at it to say, this stack is not following the rules. That's how good you have to be so you can catch problems, okay? So if you don't like reading, you're in the wrong business. You just have to constantly study, okay? Okay, so with that, let's get started. Some house cleaning rules here. I'm gonna put all the packet captures, trace files, PowerPoint, and you'll get this in the retrospective when it gets mailed out, so don't worry about it. I've been a good boy, and I got the SharkFest 2016 folder created and populated for my earlier sessions. Okay, when I'm done with this, I'll put these trace files in there as well. This is important. So this is that school of hard knocks. We all want to troubleshoot the most exotic thing. Something doesn't work, it must be because the solar wind is acting up, it's Indian burial grounds, it's something exotic, it's possessed, we got a leaky cable that only happens when the sun is at 12. Most of the time it's the stupid stuff, right? So this phrase, which in 1948 was, I finally looked up who created this because I love this phrase. When you hear hoofbeats, chances are it's a horse doing that, not a zebra, right? Unless you're in Zimbabwe. Then it might be a zebra first. So the idea is don't go looking for the most esoteric, rule out the usual common suspects. It's called the top 10 list for a reason. It's the top 10. Go through those, and most likely you'll find root cause there. I know it's boring, I know it's not exciting, but most of the time it falls in here. So today we're going to talk about School of Hard Knocks, things that I've learned. I'll show you some tool that can shred through a lot of packets so that you can find the packets of interest and quickly use surgical tool like Wireshark to analyze it. ICMP trick while capturing. So Jasper hit on this earlier. How do you differentiate? When you go on site to a customer, how do you differentiate 2 months later what the hell was happening? You think you're going to remember the transaction. You think you're going to remember the names of the steps that the user's doing, but you won't, okay? Trust me. If you have kids, you know this. The pictures you take with your children, you're like, oh, this is so special, I'll remember it for the rest of my life. 2 months later, you're like, is this my kid? Okay? You won't remember, so it's better to Jasper's point, you have to take notes, all right? Or ICMP. Whatever BPF filter you use, capture filter you use, please add parentheses and say or ICMP. Why do I do that? Because, let's give you an example. I know for a fact that there's only 2 talkers in this test scenario. 192.168.1.1, 10.10.10.10. That's it, I know. No other, it's my application, no one else is involved. I'm at the client 192.168. You might think host 10.10.10.10 is good because you know for a fact there's no one else in the world, right? Until some random router somewhere in the network sends you an ICMP message because type 3 code 4, administratively prohibited for access list. You'll miss that because Cisco, any router, sends you an ICMP message from somewhere in the network on the interface closest to you as the source. So think that through. If I'm at 192.168.1.1 and I say host 10.10.10.10, and all of a sudden it stops working because some random router sent you an ICMP message saying, sorry, there's an access list, won't let you get through, you're not gonna capture that. Because it's not 10.10.10 that's sending it to you, it's gonna be some random router. Okay? So that's the OR ICMP. Spam port gotchas, it's okay. In 10 gig world, it's not feasible. Okay, there's rate limiting at 10 gig. There's impact to the backplane. So spam port being completely safe, that ship has sailed. So if you have 10 gigs, don't span it because remember, it's not just 10 gig, it's 10 transmit, 10 receive. You're gonna outrun the buffer anyway, so you need to be careful of that. The other one, you might be using ER span where you can, basically ER span is you go through multiple switch ports. You know what, I'll show you a picture of it. And then we'll do a bunch of, we'll geek out and look at packet captures because that's what we're all here. So spam port gotchas. Let's take a look at this. This is a very common design in So this is what I call the U design, meaning the router here, 2 switches. The V design would be if this switch didn't exist, it would just be a router, and then 2 uplinks going up. So depending on whether you guys have a U design or V design, almost every data center is configured this way, right? It's not rocket science. The problem is one of these guys will be HSRP active or VRRP, meaning from a gateway, the server's perspective, everything that I'm sending out to the world will go to this side because that happens to be the HSR active router. Okay, does that make sense? Okay, so this server has a gateway address and it's going to point to this address. So the uplink, I'm sorry, let's use this one as an example. So everything will go through here. Okay, so outbound, you're going to go through here, which is great. HSRP only influences outbound decision. But from the rest of the world, I can get through this server either coming via this guy or this guy, which means the request from the client will come through here and hit the server. He'll reply going this way. No issues whatsoever until you need to capture that traffic. And then you say, that's okay. I got 2 ports here. I'll just span this link here to this switch port for spanning, and I'll span this guy over to here. I'm not going to do the whole VLAN because I don't want to capture it coming in and going out. But there's the 80-20 rule. 80% of the data goes down to the user. The requests are small and light. Okay? So notice that red bar that you see there? What you're going to do is you're going to queue up. There's going to be a serialization delay because the traffic coming this side, traffic coming from this side is tiny, request, couple packets, maybe a get, right? 10 packets, 20 packets. Whereas the stuff that you want downloaded going to the user is a couple hundred megs of data. Which means when you span this, you're going to see things like an ACK before it was transmitted. So as you're seeing it, Wireshark's going to barf and say, packet lost, or previous segment not captured. From Wireshark's perspective, it'd be 100% right. In the real world, it never happened. Okay, so does that make sense? Okay, yes? Oh, sure. So the request, I do a HTTP GET. Okay, so I open up the web browser. All it is for me is just a URL. I can do that in 1 packet. So that 1 packet comes here, and this little bar is my switch port going to the sniffer here, or Wireshark. So notice it's tiny. The queue depth here, there are not too many cars lined up at the toll booth to get to the sniffer. Whereas when the traffic goes down this way, there's a bunch of packets. They're all full size, which means it's going to get serialization delay, and people are queued up to get to the toll booth, which is a sniffer here. Think of it that way. So this is the exact problem you face every morning. You're in the commute lane with the traffic, and the people who are going counter commute are enjoying 60, 70, 80 miles an hour, 100 kilometers an hour, et cetera. Okay? Same thing happens in the networking world. You are going with the traffic, going against the traffic. Guess who gets to the toll booth first? People who are going counter traffic. Okay? So your traces will have this mysterious out of orderness, and then I'll show you how to determine, is this real or is it Memorex? No. Is it real or is it fake? Okay? So that's the kind of, and then the other one is, anybody ever troubleshoot a router that was going high CPU? Right? I'm sure most of you have. The rule is anything that terminates on a router or originates on a router goes to the CPU. That's the rule. So if you trace route, those trace route packets, because a TTL expiry message goes to the CPU. That's why there's ICMP rate limiting. Okay? Multicast, because it's hop by hop, goes to the CPU. So when you see a router that's running high, what can you do? There are some things that you can, show proc CPU, pipe it to exclude 0.00. Okay, and then you're going to see all the active processes, and then by using exclude 0.00, you get rid of 2 pages of processes that are not doing anything. Okay, And then you can see the input, the usage between interrupt and non-interrupt. So this isn't a Cisco troubleshooting class, but as troubleshooters, if CPU is high, it can impact the delivery of it, okay? Although, having said that, in a modern router, if your traffic has already been established, CPU doesn't matter. CPU can go to 100% all day, every day. It happens at the ASIC level, at this SF switching, okay? So, but it still matters because anything that deals with ACL or that needs a TCAM, like a route map, it's going to get impacted. So a nice little trick is you can use the the CPU and the route processor as the source of your packet capture, which means everything that's being punted to the CPU, you can see using Wireshark. Very handy thing to do, and you can investigate what the hell is hitting my CPU all the time, and you can find out. Okay? ER span. So ER span is where you have, say, you want to capture this guy, but your sniffer is connected to over here. So you create a GRE tunnel that goes from here to here. So basically, you're creating a special GRE tunnel so that you can span to a sniffer that's on a different switch. Okay? So that's easy enough. The only gotcha there is this packet that's coming into this port is already full size. What do you do about a GRE header? You need a GRE header to do that. So now you have to fragment the packet. Okay? So you don't want to do that because fragmentation requires punting to the CPU. So the best practice says on this inter-switch link, use a jumbo frame. Then you don't have to worry about it because 1,500 byte packet plus 24 takes you over the limit, not counting MAC address, and then you'll be fine. There's no fragmentation required. Okay? It sounds innocuous to say just throw up an ER span, but think it through because it can have an impact. And don't be like this guy that brought down a whole branch because he got a little cocky and he didn't go through his checklist. Okay? And in my defense, I had a 714 train to take, and I was racing against time, and I cut corners, and it came back to bite me in the ass. All right. So imagine my luck when I told the branch manager 10 minutes ago, don't worry about it. And the whole branch went, okay, so any questions on this spanning thing? Okay, so now let me show you the OR ICMP trick. So let me fire up Wireshark, and I'm going to capture. And I'm going to capture on, I guess it's this guy. So in this case, I'm only going to do TCP. Remember what I said, or ICMP. Okay? For two reasons. One, the ICMP message coming back somewhere from the network is important. You always want to account for it. However complex your filter is, add or ICMP. Just good practice. You never know, right? And I'm going to open up. I need to generate some traffic, so. Okay, so let's capture. And while I'm doing it, I'm going to do two things. I'm going to open up a DOS window. And I'm going to open up Notepad. And before you capture a problem application, choreograph it with your user and ask them, what are you doing? What are you going to do? And they're going to say things like login. Then account lookup. Right? Maybe, I don't know what, PO check. Okay? Use the language that they know, because when you write your report, packets 1,000 through 2,000 with this URL doesn't mean anything to the people that are reading the report. But if you tell them that PO check process was slow because of this, it makes sense. Okay? There's another reason why we're going to do this, because I'm going to put a little star after login. And I'm going to put a little star next to this guy, because as I was watching the person going through this application once or twice, I noticed there's human input that's required. So anything with a star means that mysterious delays of 2-3 seconds I can account for with human delay. You think you're going to remember, but you won't, so it's a good notation to have. Okay? Then I'm going to add this. Because I want a continuous packet capture, because the synsyn is important for the window calculation, right? But at the same time, it's kind of a pain in the ass because I have this long-running capture. How do I know when they started or stopped? If you attended Jasper's session, you can use a clock. That can be problematic because your clock may not be synced to the NTP, right? So there's that. You can use a local clock, but there's, you don't want to be too dependent on the clock because 1 minute is a lot. 1 minute is an eternity times eternity in our world. So what does that mean? So what's my IP address? So I'm going to say ping 10.255.0.1 -T, meaning continuous, -L100. So what that says is ping my gateway or whatever your control point is. Do it continuously with a -T. -L says make it 100 bytes. Okay? Well, it's really more because it's 100 plus the ICMP header of 8 bytes. Okay? So what we're going to do, by the way, for those of you that present and whatnot, I learned this from Jasper and Christian's session. It's called Zoom It, which is right here. That's what allows us to zoom in and out quickly. Okay? I'm sorry? Okay, yeah. So sometimes, just 2 seconds. So sometimes I'm very curious about what tools people use. Like I use Ultra Edit. Jasper uses Ultra Edit. I love it. I use X1 for indexing email. I can't live without it. I have RPN Calc because I'm an RPN guy. So a lot of times from a troubleshooter's perspective, it's interesting to know what's in their toolkit to make their lives run faster, easier. So it's, anyway, so, and then you can do things like, you can do like Control 2 and draw things on it. So it's Zoom It, sysinternals. Okay, so having done the commercial for that app, I'm going to run this ping continuously. Okay, so it's running in the background continuously. I'm going to put it over to the side, and I'm going to move this over to, well, actually, that's good enough. And let's go to one of my sites, okay, which is, I'm a big simulator guy, so I'm going to go, as I click on it, watch what I do. And remember, I'm not doing it simultaneously, right? I'm doing the ping somewhere else, so there's a little bit of a lag, but usually you're pinging so somebody else is pinging for you, so I'm trying to do both, so you get it, right? So as I click on this, I stop this. I wait for the page to load. I'm waiting. The user says, I'm good. I ping again. Okay? Then I stop. Then, because I'm optimized or freak, I put the -L at the back so I can just go next one. I'm ready for the next one. I start pinging continuously, and let's go to my fantasy football league. When I'm up, I stop. Okay? I'm sorry, I stopped, and then when the page loads, I do that. Okay? Does that make sense? So now, when I go to my trace file, and I stop it, notice what happens. Look at the length, okay? And as I scroll down, it's going to jump up. You saw that jump up, right? 242, because the header, it's 100 plus the header, okay? Which means in between, and you're going to see a big delta here, in between these ICMP of 100 bytes, some transaction happens, and another 100 bytes shows up. That's my marker. That's my demarcation point for login process. And then all of a sudden, I'm going to see a string of ICMP 200 byte packets, some transaction, and then another ICMP 200. So in between the 200 byte ICMP packets is my second job, account lookup. Okay? And then as you do the analysis, you can filter it out, right? Because they can be annoying or just leave them, ignore them, etc. But this way, anybody that picks up this trace file on your team, or when you pick up this trace file 2 months from now, it'll all make sense. Okay, I see a star here, that's user input, discount unusual delays coming from the client, not the server, because the input is from the client. Account lookup is a batch process. There is no human delay. It's click and go. So if I see a mysterious delay happening in account lookup, I know it's not human delay, it's an application delay. Okay? And then, so does that make sense? Okay? So this is a nice, nifty little trick that I use. And if I get rid of the ICMP, you'll see the traffic here that's interspersed with my ICMP. Okay? So a quick and dirty way of doing packet captures. Any questions on that technique? All right. So let's get rid of this. And I'm going to show you a tool that I use. And the reason why I'm showing you this tool is because it'll save you time. If I can find it. Oh, there it is. And it's called Pilot or Packet Analyzer. Some of you may have it, some of you may not. It's okay. I decided to show you this because A, it's going to make your life easier, trust me. But B, because you can get it for $29, I think, now. So, as a matter of fact, on that PowerPoint, there's if you go to Wireshark.org and go to About, there's a link that you can sign up for $29. You get this application. So, why should you get this application? Let me show you. So I have some traffic here. This is local. So think of this as I don't have an appliance, Shark appliance, but I have my own local PCAP file. It's local offline analysis. I can do things like bandwidth over time. And it comes up here. And you notice here that this is a 10-minute resolution. But in reality, I've calculated it at 1 second. So if I decide to zoom in, this utilization is at 1 second granularity. I can see what kind of applications are there. So there they are. You got some a lot of remote desktop, voice, video, etc. And you can see top conversation here. So the way this works is the bigger the circle, the more people it's talking to. Okay? The thicker the pipe in the middle there, the thicker the pipe, note to self, anonymize the IP address before recording. I just realized, and is Angela in the room? Anybody in the room help me stop the video real quick? Can we hit pause on the camera? Can we hit pause for me, please? Pressure, man. Don't mess it up. No, you don't have to worry about it. That's because I'm capturing here, so you'll have full presentation, okay? But you can watch the MP4 on YouTube, so you can, I'll blur it out. So I'm going to connect it to my Microsoft network here, and I just want to make sure I see some traffic. And let me drive. Oh, I have nothing open. So yep, I see traffic in the background. Okay, so now, the reason why I do that is because I can do things like that IP discovery. And it's waiting for, because I'm capturing live on my laptop, it's waiting for me to, there it is. I went to this 216 address, whatever that is. I can do DNS resolution up here. What I'm going to do, though, is I'm going to edit this guy. And all the things that you can make your own view if you want. And I'm going to do geo-IP lookup for destination country. And I'll drag it over here, update it. It's waiting for data for me to drive traffic, so let's do that. So let's go to this one. Let's go to BBC. Let's go to French Ministry of something or another. Let's go to something in München. I'm just driving traffic. I don't know where I'm going, actually. Oh, there we go. Well, Lonely Planet. That doesn't sound like I should click on that. Okay. And by the way, how many of you attended Jasper's session yesterday? Just show of hands. Okay. Was anybody else thinking, Jasper, click on that most visited site? Anybody? No, it's just me being nosy. All right. So the reason why I did all that traffic was because now I have country here, and I can now pivot by the country, and I can see where I went. Okay, I went to France, Germany, unknown is NATed address, so I went to some internally NATed address. Okay? So when you're troubleshooting a problem and you're global, you can pivot by country doing GeoIP to see, are my retransmissions only coming from France? Or is it only coming from Germany? Is it only coming from UK, et cetera? So pivot tables allow you to do that with the ability to drill down. Okay? So I think it's worth $30. It's like, what, 3 cups of coffee these days? Okay, with that, let's get started. The next thing let's see here. Okay. So the first one, I just want to do a quick thing here. Application disconnects. It's in the same data center, same switch. Rule out window size. Doesn't matter. Okay, even if window size is 4K, it's okay because it's on the same switch. There's microseconds of latency. Okay? Having said that, it can matter, but for now, it's not a TCP window size. It's not a long FAT network. Those types of things, take it out of your mind. Get rid of the clutter. Let's zoom in on what the problem is. This guy was actually pretty smart. He's an outstanding systems administrator. And he said, Hansang, before I called you, here's what I did. The application is disconnecting. It says in the log that the network disconnected, contact your network administrator. Pretty generic error message, but that's what he said. So he figured, okay, is it the application? Is it the network? He doesn't think it's a network because it's on the same switch port. And if there were errors, I can do show logging 1024 and see that the port was bouncing or not, right? Pretty simple to check. CRC errors, do we have any of those lately? Probably not. Most cable plants are good to go these days, no problem. So he created a ping script. Why did he create a ping script while the application was running? He divided and conquered. If the IP stack is not having a problem, it must be, by definition, a TCP or application problem, right? So if you ping, there is no TCP. So that's what he did. So he had every second he was pinging, and he was doing a capture. Actually, there was an appliance doing the capture for him. And then the application crapped out, and then it came back up. So now he realized ping stop too. That's not good. Because if ping stop, it must be network related. I'm going, but it's on the same ASIC, no issues, no log. I even went into the daughter card to look at the interface statistics from there. You can do that. You can log into the switch fabric and do commands from there. Nothing. So let's look at the packet capture. Everybody got the background on what's happening here? The intermittent problem, that's so annoying. Where am I going? I'm going to, yeah. In the enterprise, and I'm doing ICMP black hole. Okay. Let's wait for Wireshark to load. I'm not sure why it's taking so long to load. That's odd. Don't worry about it. I'll edit this out on my YouTube, so it'll be seamless. So let me close it out. Not sure why. Maybe because I record. No, it shouldn't be. Let's try it again. Might be a short day, folks. Okay, hold on. Let me. This actually has never happened to me. I mean, honestly, it's never happened. So what we're going to do is we're going to pause the recording for a second. Oh, I could have just paused it, I guess. Crap. Okay. Let me just save this before I forget. I just want to make sure that wasn't the problem. If I have to reboot, I'll reboot, but. Okay. Normally, I would have another version of Wireshark running, but this is a brand new machine, so I didn't have the time to do that. So let me make sure it's completely dead here. Yeah, it is. I'll try one last. I don't know why why I think it's gonna magically work, but it's simple, so I'll try it. No, it's not gonna do it.
Have you tried forcing an unexpected reboot?
Yeah, maybe I'll do that. Okay, so sorry guys, let me do that real quick. Wow, you know what? It's honestly, this has never happened, so I never had to troubleshoot this. It's interesting. It's very odd. Okay. Good thing is it's SSD, so it'll boot up in no time. I'm just waiting for the blue screen of death. That would be par for the course. Okay.
It might be related to, you had a capture running in Wireshark, live capture, then you had a live capture running in Pilot as well at some point.
Oh.
And it looked like those processes were still hung in Task Manager.
Well, did you see it?
Yeah, there was,
Oh, there was. Okay, I didn't see it.
there were like 3 dump cap processes.
Oh, what? Oh, you know what? Ah, damn! I could have just killed it then. I didn't see it. Okay. So now we're troubleshooting my laptop. No, that was yeah. If I was in a hurry, I didn't see it. So let me.
Sure we should download Mac Logic?
Yeah. Give me 1 second. Let me just reboot completely. There we go. Okay, now it's rebooting, sorry. You know, yeah, I mean, honestly, that's never happened before, so I didn't even think to look at the dump cap process. Which, by the way, I mentioned earlier, but if you need to do a long-term capture, dump cap's the way to go. You won't accidentally crash T-Shark or anything. So go with dump cap. Okay. All right, so let me start up my Camtasia again. Make sure my microphone is the right one. Yep, it is. And let's go to open up Wireshark before I do anything. No, let's go to my trace files. There we go, now we're cooking with gas. Okay, so when we left off, the hero was, no. So we're back from commercial, and I don't need the sequence numbers, so I could get rid of it. In fact, I can go to factory default, so I can get rid of all the columns quickly. And this is my ping. This is the problem point right here. Okay? And normally, I'm able to zoom in this quickly because DSA had a time running with each ping in his log, so I knew exactly down to the microsecond when it happened. Okay? Pretty nice of him to do that. So you'll notice that here, it's working, request reply, right? Pretty simple. ICMP has a little counter in there, So it knows which message goes which, and there's a reply. This is the expected behavior, all right? And it's fine. Everything is normal down here. That's good. I now have a working baseline. But up here, nothing is working. Why is that, right? But I know exactly where the problem occurs, which means I can micro-focus exactly the moment of trouble and find the problem. And it took about 5 seconds to do that. Why? Practice. If you practice, you go through your mental checklist. It's just as important to learn what to look for as it is what not to pay attention to. Okay? Does that make sense? Because there's a lot of information when you're scrolling up and down. So what happens between here, this request that's not working, where I'm holding it down, I do get a reply. Okay? So this is a working one. This is a non-working one. Working, non-working. Working, non-working. Changing the MAC address. Everybody see that? Okay. So why is that? So notice up here, we have MAC address. Okay. Up here, we have MAC address. And as you're scrolling down, things that change, your brain can be taught to ignore them. Human brain is exceptionally good at that. But here, notice the MAC address changes. As you're going up and down, everything else in the screen, the bottom screen there, stays steady except for the MAC address. Okay? So I said, well, that's not good. MAC addresses aren't supposed to change on the fly like that, especially coming from an Oracle-owned MAC address. Okay, the OUI resolves to Oracle. Although you can't always go with OUIs, the organizational unit identifier, because people buy blocks of address and then they get merged, and so it's not 100% guarantee. But again, we know that the MAC address changed. So I said, all right, open up the capture file. I don't have enough information, because what influences the MAC address from changing? What are some of the things that we know, the protocols that we know, that causes the MAC address to change, other than, drivers freaking out? ARP. I don't have an ARP, so there must be an ARP. So let me modify my packet capture filter. Okay? It's a logical conclusion. So I did that. So I cast a wider net, and let's go to factory default. And sure enough, just before it starts working, there was that ARP. Okay? And you can see the MAC address here of who has .254 or whatever the address is. You can see that the MAC address goes to Oracle, right? So that's good, because Oracle works. If it's Dell, it doesn't work. Okay? This turned out to be a driver issue with Broadcom chip running on some Dell servers, and it would randomly hijack MAC addresses. Not good in a data center. Okay? Now, would I have been able to troubleshoot this if I had a massive packet capture file? Yes. Eventually, as I tick off my checklist, you already know some of them, right? TCP window size, is it shrinking, expanding? I would have gotten to it, but because Pavan was so good at teeing up this with separating IP and TCP, I was able to troubleshoot it much, much quicker. Okay? Lesson learned here. Notice the MAC address changing. It's easy because we know the exact moment of the incident and see the difference. Then say, okay, I know what possibly can cause this. Open up the packet capture file, I'll cast a wider net, and solve the problem. Now, so the most obvious question is, why don't you just do an entire wide open capture? It's a judgment call. It's a judgment call because it can capture too much stuff and you fill up your buffer. If you have a reasonable suspect, start there. You can always backtrack out if the problem is persistent. Make sense? Okay? So how do you know what's reasonable or not? How do you know when you should focus your capture packet on, or not? That comes with experience. Like it or not, that comes with experience. Okay? So keep practicing. All right. Any questions on that? Let me give you another example where experience matters. Okay? Don't ignore things that are odd, because the other saying that I have always is the only thing that goes away if you ignore it are your teeth. Okay? It's absolutely true. Some of you will get it on the way home. Oh, that's what he meant. So this is a case where an application, it's a document imaging application. It works, and sometimes it doesn't work. It's intermittent. Okay, I hate those, but the good news here is I have a working one and a non-working one. So let's look at the non-working one. Okay, and because we have a lot of trace files to go through, and part one is almost over, you know, the usual, I still like to scroll down and look. I just want to know what I'm up against, so I do page down. And one thing I noticed right away is FinFinAC, SYN, There's a lot of connections happening. How do I know? Because as I'm scrolling down, look at the column on the right, you can see it. You can absolutely see the FinFinACs happening, okay? So it's chatty, okay, I get it, right? And then because I'm not in my thing, let me go to my default. I can do TCP analysis. No packet loss whatsoever, clean as a whistle. So that's not it. I can go to my delta and look at it, okay? And you can see here, oh, this is not good. 15 seconds of delay, 120, okay? Although the 120 is a little suspect for me. That's too close to 120 seconds. It might be a timeout application, or it just waits 2 minutes, okay? So when you see numbers like that, 60, 45, 120, it's not it's happening for a reason, okay? So that might be additional clue, or it might be something you can completely disregard. The other thing that I do, because I don't know, I want to compare a working with non-working one, is I look at conversations. I always do this. And just as I suspected, there are 207, and you call up the application guy and says, yeah, we open up an application, we transfer a little bit, we check for, you know, are you still there? Download small images. Not here to judge. So you want to open up 1,000 TCP connections, knock yourself out. Although in the back of my mind, I'm starting to think maybe there's port reuse problem. If I open up this many connections and there's a bunch of people, I might be stepping over because I'm opening up too many damn connections, okay? So I might think about that. All right, so this is a non-working example. Let's go to the working example. I don't care about this guy anymore. So this is from a branch that's working. And as you scroll down, same behavior, sort of, kind of. Not as many connections here, but I can see fins flying by. I can see that there are no TCP analysis. And when I scroll down to the highest delay, now it's 70 seconds, but these are interesting because these are kind of seem random. Although the 16 and 32 might seem a little suspect, okay? So I'm not here to troubleshoot a performance problem. I'm here to troubleshoot it doesn't work problem. Very different sets of problem. Performance problem, set that aside because we're looking at things like TCP windows. This one is not working at all. So we go to statistics, conversations. What's different about this and then the other conversation? I'm sorry? About half, okay. Volume is different. What else? Let me make it easier and go to this guy. This is a non-working one. This is a working one. Okay? And it's different time slices, so the number of connections and whatnot may change. But so non-working, working. When you're experienced and you're looking at information quickly and fast, things will jump out at you. But again, it takes practice. That's what I'm trying to show you out. Trying to show you. Okay? As I switch between back and forth, what jumps out? Anything? There is and I know in the back of your mind, I know what you're thinking. That's BS, man. You can't be looking at that crap and find it that fast. You can. It just takes practice. Okay? You can. It takes practice. Look at these athletes that that can shoot a three-pointer in their sleep and make it. It comes with practice and God-given talent, I think. But what's different about this versus this? There's a big difference. Here, there's a UDP packet. What's that about? Immediately you think, oh, DNS. Probably. Let's check. It's not. Look at the port number. Look at the byte count. It's consistent. Look at the addresses. 10.10.10, 192.168.1.1. The very same client servers that's involved in this TCP address, but no UDP here. So this UDP is not some random UDP. It's not port unreachable. Okay? It's not even a Unix-based trace route. It's not DNS. What else could it be? Well, let's call the vendor and ask them. Excuse me, I notice you're using UDP packets. Is that meaningful? Oh, yes, we checked the license that way. So that was it. It was as simple as that. And why did it not happen on the other side? Because there's a what? That when you talk to an external vendor, there's a firewall. And can you be 100% sure that all firewalls have the same rule? Of course not. And so that was a problem. Okay? Different firewalls going to a different, and it wasn't 100% synced. How did I find it? By noticing that there's a UDP packet in the one that's not working or working versus not working. Okay? These are all part of your tooltips that you need to learn to use to bring to bear. And I didn't look at the TCP window size because, again, I'm not looking at a performance issue. Okay? I am looking for window size 0 because that just means the application says stop. That's a possibility, but I'm not looking at a performance-related statistic. Does that make sense? Yeah? Okay. So, you know, I asked a professor of mine in my strengths of material class, and I was kind of like saying, you know, some of these classes, I'm never going to use it. Do I really need to pay attention? Why am I doing this, right? Every students have asked that question, time immemorial. And she told me something that I'll never forget. She said, Hansang, you are a toolbox. You go to university to collect tools. That's your job. That's all you do. We're giving you, arming you with how to use a particular tool. When you go to your job, they'll teach you what you need to know, but they'll say, you need to do this. You reach into your tool bag, take it out, and use it. Okay? So Fourier analysis, complex variables, differential laminar flow, all the things that, or algorithmic, you know, on the computer science world, you know, binary versus quick bubble sort, things that we've all done, right? It's a toolkit. So packet analysis is the same thing. Learn the workflow, don't deviate, so you can catch these things that are exception-based. Okay? I sound like I'm preaching, but I kind of am. This is more art than science. I can't give you the perfect flow chart. I can give you a flow chart that's about 70, 65, 70% complete. Most of the time, you follow my workflow, you will get to a person of interest very, very quickly. Okay? And we're going to see that in just a second. But it only takes experience. So there's a lot of art involved in this. Any questions on that use case? Okay, all right. All right, so let's look at some more examples. Some of these are kind of quick and dirty. And then I want to get to this load balancer problem in just a second. Okay, so let's look at this guy. FP loss final. I have no idea what that means. But I have a clue here. It says look at either packet 119 or stream 119. So if I do conversation, there's 119. So it could be both. It could be packet 119 or it could be stream 119, right? Because there are 193 TCP sessions. So let's check both. Oh, actually, you know what? Let's use our workflow, right? So this is some problem of some, I have no idea what the problem statement is. I wish I could tell you, but I forgot. And then I made the name kind of cryptic back in the days because I don't want to, like to Jasper's point, I don't want to open up a trace file that says evil out packet and then expect you to troubleshoot it because chances are it's an evil out packet that you saw. So it's cryptic for some reason. Some loss is going on. It's final, meaning it's ready for presentation. These are my little shorthands that I use. So let's go through my workflow and So there's probably an IPsec GRE tunnel, because look at the packet size, 1254, right? 1380. When you see numbers like 1380 in the length column or 1254, mostly it's because you have a GRE with an IPsec or PPOE. MTU needs to be cranked down. So, okay, there's probably an IPsec involved here. It's pretty, I see chunks of data, right? There seems to be spurts of data. Everybody saw that, right? There's a bunch of 12 somethings and then a bunch of ACKs. Okay, that's good. Then let's look at TCP analysis.flags. Okay. What's the problem here? Why are these things highlighted? And I don't have any informational because I have a calculated window size. Let me remove that. And let me move the column. When you change the resolution, it kind of throws the workflow off. But TCP ACK unseen segment. Well, that's no good. What does that mean? TCP ACK an unseen segment. It means TCP acknowledged something, but I didn't see it go by. So clearly you sent it to me because I acknowledged it. I just didn't see you transmit it, that's all. Immediately, what do I think is the problem? If you see TCP acknowledged unseen segment or previous segment not captured, what might that lead you to conclude reasonably?
Never captured it in the first place.
Different capture point, you said?
Yeah, I mean, it could be a split router.
Okay, split router, there's my zebra. Multiple interfaces, okay. Half a zebra. Where's my horse? Wireshark couldn't keep up or the span port couldn't keep up. All three are 100% correct answer, but the horse is probably the span port or Wireshark. Okay, span port's easy, show port, see if there's any drops. Okay. Now, the thing about the alternate route theory is here, a little bit apropos, because it's consistently happening. Okay? When you see it once in a while, it's not a multipath problem. Okay? Because trust me on this, modern day networks, once you do a Ceph path, you do label switching, that's it, you stick to that path. Okay? So you're not going to flip-flop unless you do per packet load balancing, which you shouldn't, and you should stop it right now. So don't do that. All right. So looks like we got some packet drops. Okay? Is this a performance problem? Let's see. So I'm going to go with TCP, well, let's see. I'm going to go to the cooking show mode, and I'm going to look at this guy first. Okay? Because it could be packet 119 or stream 119. I would have taken better notes, but I didn't, so follow my own advice, right? Take good notes. I didn't. So let's go with prepare a filter. Or there's my, okay. So this is my 119. Do I see anything obvious that jumps out here? There is a 99 millisecond delay. So that's interesting, right? Everybody see that? Okay. So that might be interesting. We have TCP acknowledged unseen segment. All right, let's go take a look at that. Maybe that's what I meant. So let's do sequence number analysis, shall we? So who's the sender? 10 dot is sending to 192.168, right? And 192.168 is acknowledging. Okay? So that's good. So let's back up 10, 20 packets or so from the problem, potential problem of interest. 99 milliseconds of delay. We have 36, 15. Okay? So let's see if there's a problem here. Okay. I'm sorry?
I was going to say between 128 and 129.
Yep, 128 and 129. There is a 36 millisecond delay. Okay. But is that a problem? Is 36 milliseconds of delay a problem in this particular trace with what you see on the screen right now? Okay, again, it comes with practice. Make a snapshot and say, that's not a problem. Move on. So I'm sorry, I can't, because there's fans going. Okay, so if you look at the first 3 packets, SYN, SYNAC, and ACK, there is a round trip time of 35 milliseconds. So the fact that there's a 36 millisecond delay is nothing more than a round trip plus or minus fudge factor. So that in and of itself is not a problem, okay? See how fast we did that? Okay, these are things that these are reptilian brain things that should happen as you do packet capture analysis, okay? All right, this one though is still of interest. What happened? Let's take a look. Let's take a look at why this TCP acknowledgement unseen happened. All right. So we come to here, a couple packets up. So let's start from here. Okay. So my sequence number is 9601 to 10801. The next one is 1201 to 13201, 13201 to 14401. What just happened?
You missed the packet.
Yeah, I missed a packet. Right? So let me do that again. I have 9601 to next expected sequence number 10801. I'm supposed to start with 10801 next packet. That's why it says next sequence number. Okay? And I thank God Guy put this in every day because it's pain in the ass to calculate. It used to not show you the next expected sequence number. Doesn't seem like it's a hard thing to calculate, but when you're doing it fast, you know, thank goodness Guy put it in. Guy is one of the original core developers. He did it because he got tired of it too, so I thank him. So 8401 to 9601, 9601 to 1008. Let's back up a little bit. 6001 to 7201, 7201 to 8401, 8401 to 9601, 9601 to 10801, 1200. We have a problem. Is this a real problem or is this a BS problem? It's a missing packet, something is wrong is one side. What's another side? What happens in the real world when a packet goes missing? When a chunk of data goes missing, what happens to that data? Retransmit. Do we see retransmit here? Yes or no? We don't see it, so maybe this is a fake indicator of a problem. Okay? Does that make sense? Now, now I remember what this problem. If you, FP now, I just realized what that FP stands for. It's fake packet loss. As I was doing it, I just realized why I called it FP. It's fake packet loss, okay? And you'll see this behavior happen again and again and again. I can pick any conversation and the same thing happens. And not once is there a retransmission. And you can make an argument that because I'm oversubscribed on my span port, the retransmissions are missing. Okay, I'll give you that. I'll give it to you for the first one, the 10th one, 50th one, but not after 200 times of happening. Every time I missed a retransmission, nonsense. Okay, not likely. So the lesson learned here is don't go down the rat hole. Learn to identify these false positives and ignore them. It's annoying, but ignore them. Okay? Just because Wireshark tells you that there's a problem, it's not a problem. Expert system can only deal with what's available here, and the data is not good. Does that make sense? Okay? So it's just as important not to go down a rat hole and say, aha, I found the root cause, packet went missing? No, because there's no retransmission. So now you have something in your toolkit. When you see these previous segment not captured or lost, you're going to look for a retransmission. And if there is a retransmission, that's a legitimate problem. Okay? But if you see fast retransmission, for the most part, ignore it. It doesn't matter. It doesn't hurt you because it's called a fast retransmission for a reason. Okay? Unless you step up and realize it happened in the same window. Then the pipe's going to drain. Okay? So why do I say these things? Because I want you to read the RFC. I want you to go study and understand TCP. Okay, so we have 2 minutes before we take our break, and we go into, you saw my list, we have a bunch of other trace files to go through. The load balancer one is going to take a while. RMD, I'll figure out what that is. It was pretty late at night. External apps flow, I'll figure out what that is. But I want you to think about this, okay, before you go. So I was talking to somebody yesterday. A lot of people say they know TCP. Really, they don't. I don't know. I'm still learning. when TCP says guaranteed delivery, how does it guarantee the delivery? Okay, I want you to think about these as a troubleshooter. There's TCP book knowledge, there's TCP analyst, packet analyst knowledge, okay? Why does TCP say it's guaranteed delivery? Because it makes a copy before it puts it onto the wire. And that copy goes into the buffer, the send buffer, the receive buffer. So when a packet goes missing, that means a chunk of data went missing. What does TCP do? TCP goes into this buffer, makes another Xerox copy of that data, and puts it back on the wire. Because TCP can't go back to the application and say, sorry, I missed that. Can you give me that print job again? Okay? This is why if the send buffer is full or the receive buffer is full, it stops transmitting. Unfortunately, send buffer is not exposed except for at the source code level, at the socket level, but reasonably conclude it's the same as the receive window. Okay? So that's why TCP can... Now, I bring this up because what happens if 3 small packets go missing? So packet number 567 goes missing, and they're carrying 100 bytes each. So imagine a packet train of 10 leaving the station, 5, 6, 7 go missing, they're all carrying 100 bytes to make the math easy. What does a retransmission look like? Is it 3 packets, 100 bytes each, or is it 1 packet, 300 bytes? Because remember, they're contiguous. I made it contiguous in this example. Depends. But most likely, you're going to see it clumped as 300 byte going by. So why do I bring this up? Because if you're doing sequence number analysis, you may not see the sequence number of that retransmission because the range is now not 100 byte boundaries, but a 300 boundary. So don't get caught up in saying, I can't find this using sequence numbers because it could have been combined into a big packet. Okay? This is a troubleshooter's view of TCP retransmission. That's important, but not academic TCP, because we have this buffer that we can go back to. Okay, does that make sense? Also, I want you to remember this. It sounds odd. Don't concentrate on the packets. Concentrate on the data. TCP could care less about packetizing. It's not its job. TCP doesn't packetize data. Okay, IP wraps it up and an Ethernet transmits it. TCP is called a stream-oriented protocol for a reason. It's a stream of data. There is no beginning, there is no end. It's just data. So when you think in terms of that, things like 3 packets going missing, really in your mind, you need to translate that as certain amount of data went missing. How is TCP going to handle that? Okay? When you concentrate so much on packet, you're looking at discrete packetized data, and that may change. It may change because you're using TCP offload, and you might see a 16,000 byte packet, okay? But in the real world, we know, unless you're even jumbo frame as big as 9,000, but you can still do the analysis because if you do it from a data perspective, the packetization doesn't matter as much. Although we call it packet analysis, in the back of your mind, always think about that it's data, okay? All right, so we got 15-minute break. Plus, I'll give you 2 minutes. So AIS time has been increased by 2 minutes. And we'll go into load balancing problem. We'll go into external app that's slow, and whatever RMD is.